Hello everyone, welcome to our third week of severe weather forecasting and the basics of severe weather forecasting. So the last 2 weeks we talked about a trigger and we talked about instability. So just a really brief review, we learned about troughs and fronts and cold fronts and warm fronts and instability. So the trigger was needed to form thunderstorms in our area, which we established would probably be Kansas, Oklahoma, Texas, somewhere in this situation. And the instability was needed to be looked at to know how buoyant the atmosphere is in that area. So where the atmosphere is buoyant, basically where there's the most instability and parcels will rise, this is where your pockets of thunderstorms or the most severe thunderstorms should occur. Now we're going to talk about something else. And since we know that the trigger will basically kick the atmosphere in the bum to initiate thunderstorms, now we know that there's instability to support fairly strong thunderstorms. Now we want to know how long these thunderstorms will last. And to look at that, we need to look at moisture. So before we talk about this, we're going to actually talk a little bit more about fronts. And because these become important when you're looking at moisture. So we're just going to pull the maps for fronts, and we're actually going to use dew point. And dew point is moisture. So we're going to look at this for our area. So this is for Tuesday. So you can see that there's a lot of instability in the eastern Oklahoma area. And if we look at the moisture, here it's in moisture is expressed in basically in Celsius, or in this case it's in Fahrenheit, but it's a temperature. It's basically a temperature depiction. So we can see the wind barbs here. They're bringing the winds from the south, from the Gulf of Mexico. It's really moist air, and it's going in some kind of low here, and it's moving this way. So you see all this area here. That's all dry air, cold air, most likely. And down here, you have a gradient where it goes from 34 Fahrenheit to 40, and then 60s, and then you got 70s up here, right? So this is eastern Oklahoma. This is the area we're looking at for severe storms on this day. And you can see that 71 Fahrenheit is fairly high, especially for 1 p.m. So we can look further in the day. But it seems to be maintained around the 70s, which is really high for this time of year. So it's because of this low here. This low, I think you can see it here. There we go. This low here is basically grabbing all this air and making it turn anti-clockwise. Yeah. So the moisture, we usually look at moisture at the surface. It's not very useful for us to look at moisture in the high levels. So you usually want to go into your surface and precipitation parameters and look at the 2 meter AGL, means 2 meters above ground layer. Like in your surface chart here, you're gonna pull that, and you have your depiction of the moisture here. So you have some kind of warm front up here. So we're actually gonna draw it. Why not? And I'll show you. It's very simple. So when you're going to draw a front, you're basically looking where the winds are changing, where the temperature is changing, in this case, where the moisture is changing. So we know there's a low up here, and we know there's some kind of warm front up here. It's okay, don't quote me on this, it's very rough. And we know there's going to be there's There's cold air up here, but there's dry air mostly from the deserts down here. So it's going to be some kind of dry line down here. I won't get too caught up with these things, but basically fronts become important when you're looking at different air masses. In this case, we're looking at mostly a warm front dry line kind of scenario. But anyways, that's how you would draw that kind of front. So we look at it in terms of moisture, but we can also look at it in terms of temperature. You see there's a sharp temperature contrast from almost 80 Fahrenheit up here to 40s, right? So there's some type, that's probably a cold front up here. And it becomes important to look at moisture because of thunderstorms. So why do we need to look at moisture? Well, we know there's going to be thunderstorms in this area up here, and we know that they're probably going to explode into cumulonimbus clouds, and they're most likely going to produce severe weather. But now, what will happen once they blow up, once they become cumulonimbus? Will they die? You know, sometimes you see a storm in the summer, it explodes and then it dies right away. Or sometimes, you know, it becomes a really big storm and then it lasts forever, right? It lasts a really long time. So to know how long a storm will last is with the amount of moisture they will have. So if we look back at our simulated reflectivity, we see that these storms are blowing up because of the trigger. We see that they're intensifying here because they hit those pockets of instability and high moisture content in that area of eastern Oklahoma. And you see they're lasting, and eventually they'll die. They'll die here in Arizona. Sorry, Arkansas. That's Arkansas. Why do they die up here, right? Well, if we look back at our moisture, and we go forward in time, you see that eventually the moisture moves off. It's not very good for thunderstorms anymore. So there's different websites you can look at moisture. This is another website. It doesn't go into the very local areas, but it's a good website for looking at the bigger pattern that's going on. So if we look back at our trigger, you see the trigger up here. You see the trough ejecting. You see the stronger flow up here in Oklahoma area, central Oklahoma, and then we look at our instability, and we see some pockets here of fairly high instability for this time of year, and then we look at our moisture, and we got pretty good moisture here. You got 70s in the same area. There is a magic number for storm chasers. Usually there is, you can have too low and you can have too high. So usually when you're talking about 70s, in the mid 70s dew point, like we have for this day, that would be a fairly high, a bit too high in my opinion, because you'll tend to have more high precipitation storms, very loaded with moisture, and if there is any kind of tornadoes, you're probably not going to see them because they're going to be wrapped in rain. And this kind of scenario is more favorable for squall lines. We can talk about different types of storms later on, but usually the magic number is around 64, maybe 65 Fahrenheit, and it's pretty good number for moisture you want to look at. So whenever you have all these ingredients coming together and you have 64, 65 dew points, you're looking at a pretty good scenario for severe weather here. And if you're looking at the below 60 Fahrenheit, it's usually not enough. So the storms will kind of starve themselves, and they won't be as great as you want them to be. And above 670s, like I said, is a bit too much. So you might have more high precipitation storms that are favored, or merging storms. So that's it for moisture. It's pretty straightforward. Like I said, you look at your surface charts here. And next week we're going to talk about the last ingredient is shear, wind shear. So this one's a little bit more complicated, but this is the last thing we look at, because now we know there's going to be triggers. So there's going to be thunderstorms in this area, and there's going to be instability, pretty strong instability. We established that the magic numbers for instability is usually, you know, between 1,000, 3,000 and upwards. You can have all kinds of instability. And then moisture, so we know that the storms are going to be explosive, they're going to be long lasting. So the last thing we want to know is, will these storms be supercell storms? Will they spin? Will they rotate? And to know that, we need to look at the wind shear. So we're going to talk about that next week. If you have any comments about this week, just post it in the comments. It's a really brief review, so if you have more specific questions, just send us a message on our page there. You can go to our website, and we can send you all these model websites so you can take a look at it yourself.